I should not go like this. Identifying appropriate generator for wind energy conversion system. Because the wind speed is varying, so we cannot decide that the characteristics of the machine should be one. So we should have flexibility to have the characteristic anywhere in the speed range. If I talk about motor, so this is how for different frequencies the operating point is shifted. When it comes to a generator, for a different speed, the corresponding characteristic will be chosen. So you will have to extend this characteristic. So by having power electronic converter connected to the stator windings and then to the grid, we will have the wide speed range. Next one is a synchronous machine. Synchronous machine, once again the same story, you want to have a wide speed range operation so that you can have a power electronic converter which is a frequency changer. Some frequency, certain frequency coming out of the synchronous generator and you want to feed it to 50 hertz grid, so obviously there has to be a interface. And for feeding DC excitation to the field winding which is sitting in the rotor, so we have another rectifier. So therefore the power flow is only, this is a unidirection. To establish the traveling magnetic field, we require a reactive power. This part we have already seen. Whether it is a synchronous generator or a synchronous generator. So if you, basically you require two fields here. So one field is established by the DC supply and another field will be automatically come because of that. If it's a motor, right? If it's a generator, then you are providing a mechanical power and EMF is induced and that is what you are feeding it to the grid with the help of frequency change. If I take speed on the y-axis and torque on the x-axis, so this is what is going to be the motoring mode. The speed of the motor is constant irrespective of the load connected. Whatever may be the load added, the speed is always going to be constant. Right? Suppose if you take speed on the x-axis and torque on the y-axis, then you will be having a vertical line. Any question here? Once again, it's also wide speed range, right? Just because we are having a power electronic converter. Any question? Induction machine is widely used, that too phase wound induction machine. When I talk about induction machine, we have three-phase winding in the stator. The rotor could be a squirrel cage wherein you don't have windings, just a short-circuited copper bar or aluminum bar. And we have another machine, phase wound machine, wherein you have once again three-phase windings in the rotor also. And to access those windings, because it is in the rotating part, so you can't directly take, so obviously some interface is needed. That is a slip rings and brushes will be there. There is a big difference between slip ring and commutator is you will have the insulation between two consecutive segments, whereas here it is a continuously conducting cylinder. Inventor of this asynchronous machine, induction machine, is Nikola Tesla. Okay, induction machine is induction motor is one of the top 10 inventions in electrical engineering. Okay, this is what I made in the regular class also. I made a very powerful statement about Mr. Nikola Tesla and the contributions made by him. Induction motor is one of the top 10 inventions in electrical engineering. One first year student said, could you please list out the remaining 9 inventions? Right? Most of the time problems are not created by others. Right? So then I will have to manage. When the problems are created by me, I have to manage. See, I know a lot of things, but the semester duration is just 14 weeks. So can we take this discussion offline? Whenever somebody says no, can we take the discussion offline? That will never happen. Right? So often, no, that guy used to catch me in the campus. Sir, please list out the remaining 9 inventions. Okay? So whenever he comes this side, I used to take a different route and then go. Then also you will take a different route and come, so please list out the remaining 9 inventions. It's not like that I was very curious to know about the remaining 9 inventions, but I want to sell my idea. My idea is what? Nikola Tesla is great and induction motor is great, and whatever electrical power is generated all over the world, more than 80% of it is being consumed in the induction motor. I want to sell that idea, so I made a statement, which statement is correct. Induction motor is one of the top 10 inventions in electrical engineering. There is no doubt about it. But I never had shown curiosity in knowing about what are the remaining 9 inventions. Even he was also not interested, but fortunately he completed the degree and left. Otherwise, no, it was like hide and seek game in the campus. So please list out the remaining 9 inventions. This is the setup that we have in IIT Gandhinagar. Just I want to show that what's the difference between the size of the squirrel gauge induction motor and phase wound induction motor. The first one is a squirrel gauge induction motor, okay, and this is a phase wound induction motor. So by then also I did not get an idea. So I was requesting my students, I want to know the size. So we kept a marker here. This idea was by students. My students are here. So they kept a marker here. So you can compare the size. So this rating is 2.2 kilowatt, and this one is a 1.5 kilowatt. But they did not keep a marker here. Okay. I was asking, so you took a photograph, kept a marker here, I can compare, but here, then again they were very clever. So marker is kept, but the base is same in both the cases. So from this, you please estimate what may be the increase in size. Okay. Actually, they missed it. Just to, what do you call that? Just to cover up, they are saying that since this frame is same, from this marker you estimate this length and then you predict or estimate the length of this. Obviously, this is bigger than this for the lesser rating. There is a more heat produced, right, because we have windings. Okay. Important thing is this second machine, phase wound induction machine, is widely used for wind energy conversion system. That's what we are going to see. What is shown here is the rotor. 3 windings are there. Those 3 windings are connected to the slip rings and brushes. Now you can have a star connected resistances to this. Basically, you will be able to vary the resistance of the rotor, right? Okay. I'll come back to this characteristic. So the first blue color corresponds to the resistance is 0 because no resistance is added. Basically, all these terminals are being short circuited. And if I put some resistance, then the characteristic gets shifted here. Whereas this point will not change because we are not altering the frequency of the supply. That will remain the same. And if you add some more resistance, the characteristic gets shifted. So basically, you are able to shift the operating point from this point to this point, and so on. And also, if you see, the starting torque is also changing. By adding the resistance, you will be able to increase the starting torque. So whenever you have a higher load, by having higher resistance, it is possible to start the motor with ease. But it is not going to be efficient. Whenever in any electrical system, adding resistance is not efficient. Similarly, in a magnetic system, adding dash is not efficient. In electrical system, electrical circuit, adding resistance, whatever may be the purpose, maybe for control or whatever, adding resistance is inefficient one. Similarly, adding dash in a magnetic circuit or magnetic system is inefficient. Analogous quantity of resistance in magnetic system is reluctance. Great. Right. Sometimes no, it is needed. If there is a possibility to get out of it at the earliest, it will be good. So here to increase the starting torque, we are adding resistance, and also to change the operating point. Okay. When I add resistance, the speed of the motor decreases. And first I will talk about motor, then I will go to generator. The speed of the motor decreases. Speed of the motor decreases in the sense slip increases. Slip is what? The difference between the speed of the magnetic field and speed of the motor, the slip increases. The power that is crossing from the source to the rotor, it is called air gap power. this is the air gap power. This air gap power, most of it will become the mechanical power. Some amount will be lost as rotor ohmic loss. Right? In the book it will be written P subscript Cu, copper loss, but I am saying ohmic loss. This ohmic loss is SPG. Okay? Where S stands for slip. Slip times the air gap power is the ohmic loss in the rotor circuit. So PG is crossing, some amount is lost in the rotor circuit and the remaining is available as the mechanical power. If I consider the efficiency of induction motor for some load is 85%, then 15% has gone as ohmic loss in the stator windings, ohmic loss in the rotor, and then core loss, stator core, rotor core, and then friction windage loss. Okay. So all these has gone as 15%. So most of it is available as a mechanical power. So this is slip into air gap power is the rotor copper loss. As the slip increases, so rotor copper loss contribution is more and the remaining is the mechanical power. Output mechanical power is equal to air gap power minus the rotor copper loss. Forget about friction and windage at the moment. Right? So to shift to the operating point, what we are doing, you divert some power in the rotor circuit. In one case I am saying rotor copper loss, that means what? You divert some power in the rotor circuit and the remaining power is available as a mechanical power. If the power that you are diverting in the rotor circuit, if it is increasing, then the mechanical power will go down. But we are not bothered about mechanical power going down. What is it? The speed is getting shifted. Speed is being pushed to the low speed range. Whether that is understood? Okay. We have to divert the power in the rotor circuit. Instead of wasting that power in the resistances, can we make use of dash? You please look at that screen and then tell me. Instead of wasting power in the rotor circuit, we will have to divert the power. Basically there are two things, mechanical power and some power is being diverted in the rotor circuit as a loss. Instead of diverting the power as a loss, you have to do something with the help of Anji? Power electronics, very good. Whenever I start the course power electronics, I have told in the beginning, any question that I ask, you say simply keep saying power electronics. How is it possible? Power electronics. Why? Power electronics. Anything. Suddenly I ask, what is your name? Power electronics. Right? So only that little bit of alertness you should have. Otherwise, no, for 10 questions, at least 7, 8, it will be correct. How is it possible? Power electronics. Right? Air gap power is PG. Power that is being wasted in the rotor circuit is SPG and the remaining is available as a mechanical power. Now this source that is connected to the stator, it thinks that some power is being dissipated in the rotor circuit. Now we are going to do some trick. It thinks that something is wasted. Now we will not waste it. We will remove this. What we will put? SPG is coming, right? Before independence. After independence, we can put converters, right? So SPG has to come, then DC is converted to AC and feed it to the grid, right? Then also the same thing we are able to achieve. Obviously this is efficient, right? But this is possible only for phase wound induction machine, because then only we can access the terminals of the rotor winding. Otherwise we cannot add the resistance in a squirrel cage induction machine. So typically the value of slip is, let us say, 4%, and if this is a 50 Hertz, this will be 2 Hertz. The frequency of rotor current, the frequency of the stator winding current is 50 Hertz, frequency of the rotor winding current is 2 Hertz. So therefore here you have a AC supply of 2 Hertz that you are converting into DC. Then it is converted to 50 Hertz. Right. Now whether it should be uncontrolled, obviously this has to be a controlled inverter. Okay, it has to be of transistor family devices, BJT, MOSFET, IGBT. What about this? We want to convert this 2 Hertz AC to DC. What about this? Should it be controlled or uncontrolled rectifier? Now I want to convert 2 Hertz AC to DC. DC is transferred to DC is converted to AC and then fed to the grid, right? So it is possible to achieve uncontrolled also, right? We want to. If you are looking for the power flow in the opposite direction, yes, it's controlled. But as of now, whatever I have explained now, it is okay to have uncontrolled rectifier. Agreed? Just you have to convert to AC to DC. But there is a situation. Now, instead of shifting the operating point to, I want to have somewhere here. This is whatever I have explained is a below base speed. Instead of shifting the operating point to, I want to shift the operating point somewhere here, above speed of the magnetic field. Is that possible? What will be the slip? Positive or negative? Negative. Okay. Negative means what? S into PG becomes negative. Negative means what? Now, right now I have said power is flowing in this direction. I want power flow to be in the opposite direction. If it is possible to inject power in the rotor circuit in the opposite direction, then the operating point will be here. Do you follow what I am saying? Right? So, this asynchronous motor, if you refer the book, induction motor always rotates at a speed less than the synchronous speed, which is not correct. It is an asynchronous motor. It will operate at any speed other than the synchronous. Only at this point it cannot operate, but it will operate at any speed other than the synchronous speed. Right? But for that, the power has to be diverted from the rotor circuit if you want below base speed or below synchronous speed. But if you want that operating point to be above synchronous speed, then the power should be injected actually. Right? So, therefore, in that case, it has to be a controlled one. Okay. Because we want. So, controlled one, and when you are feeding the power, it's a 50 hertz supply. Now, I am talking about feeding the active power in the, it's active power. Okay, because it is originally it was rotor copper loss. Now we are doing a manipulation to the stator supply. We don't want to waste it. With the help of power electronic converter, this is called slip power recovery scheme. Okay, slip power. So now we want to feed. In one case, 2 hertz supply is converted to DC, DC is converted to 50 hertz. So this control is always fixed frequency because we know the grid frequency is fixed. So 2 hertz, converting 2 hertz into DC is also okay. But when you talk about shifting the operating point above synchronous speed, that's called super synchronous operation. So for whatever we have seen is subsynchronous. Subsynchronous operation is possible with a squirrel gauge. With a squirrel gauge motor, it is not possible to have the operating point above synchronous speed, right? Whereas with the phase wound induction machine, you can have the operating point anywhere here, super synchronous possible. So then we have to feed it. Already you have, I'm talking about motor, I will go to generator just after this. I have a three-phase supply in the rotor of different frequency, different voltage. Now I want to synchronize this 50 hertz supply with that 2 hertz supply. Whether it is a 2 hertz, 1.5 hertz, 1 hertz, that is not known now, right? It's all connected with the operating point. Operating point in the sense, what is the torque you want, what is the speed and so on. So while feeding, if it is a 1.7 hertz, so that synchronization has to happen properly. This is also 3-phase supply and this is also 3-phase supply, different frequencies. So this 50 hertz converting 50 hertz to DC, no problem. But this DC has to be converted to 2 hertz, 1.7 hertz, 2.4 hertz, depending on what is the frequency of that. So and once again, phase sequence, phase, voltage, phase angle, right? When this is crossing phase A supply crossing, then this also has to match. So this, there is a control complexity here, right? Whereas subsynchronous operation, 2 hertz converted to DC, DC is converted to 50 hertz, right? And fixed at frequency, there is no problem. But when it is about super synchronous operation, again 50 hertz is converted to DC, there is no problem. But DC to what is a frequency, what is a voltage? So there are some challenges. So induction motor can operate at a speed more than the speed of the magnetic field. That's what the takeaway. Now you come to the generator. Generator. Rotor is being rotated by the turbine. No. So for generator, you will be referring to this. This is a subsynchronous operation, super synchronous operation. What you might have studied, those who have studied induction generator, for the generation to happen, the rotor should be rotated at a speed greater than the magnetic field. Correct, no? So that one corresponds to this point. If the rotor is rotated by the turbine, you get mechanical power from the turbine and it is rotated. Once again the same story, some power will be diverted in the rotor circuit and the remaining will be transferred to the grid, right? So active power is transferred. But for the generation to happen, you require a magnetic field. So the reactive power support is by the grid. Reactive power support is by the grid. Understood? Don't say reactive power is drawn from the grid. Reactive power means it is oscillating power. So you cannot use reactive power is supplied by the grid, reactive power is absorbed by the motor, all that is not appropriate. It is an oscillating power. Okay? Reactive power support is established with the grid. That's all I can say. Right? So we have, whereas P I can say, active power is delivered to the grid, sent to the grid. That I can say because it's unidirectional power, whereas reactive power is a bidirectional, oscillating power. So you cannot use the word delivered to the grid or drawn from the grid. So this is for supersynchronous operation. If the rotor of the induction machine is above the speed of the magnetic field, then the power is getting transferred from the rotor to the stator. So that is a generator operation. That time, depending on what is the wind speed and what is the torque produced by the turbine, so that decides the operating point. That whether it is close to this point or slightly away from that, right? So maximum up to this point only, because for the machine to operate as a motor also, somewhere here only is a full load operating point. You cannot think about this. It is, thumb rule is 1/3 of that point. So it is somewhere here. So similarly, this is a full load operation, right? Depending on its the power that is coming out of the turbine because of the wind power, so operating point is anywhere here, right? Once you know this is the operating point somewhere here, so you can find out what is the slip, right? So that's S into PG. So that control you will be doing here. So that much power is being diverted to the from the rotor circuit and finally it is injected to the grid. Now if you want to have the operation of generator, so basically S is what? Negative, right? Negative means you are taking the power from the rotor circuit. Whenever I say taking, that means active power. Rotor means it's associated with active power. But if I want to, there are some situations where the wind speed is less, but you have sufficient mechanical power. Only thing is that speed is less than the speed of the magnetic field. Just because the speed of the turbine wind speed is such that the turbine speed is slightly less than the speed of the magnetic field, you cannot say it will not operate as a generator because huge mechanical power is available, right? Instead of 1550 RPM, it is a 1450 RPM. But we cannot say it will not operate as a generator. Only thing is we will have to enable that control so that generation is happening now also. So when it is somewhere here, then slip is positive, correct? Slip is positive. So then the power has to be fed to the rotor circuit. Alright? So now the generator will be operating as an induction generator in a subsynchronous operation. So motoring mode is possible above synchronous speed, generating mode is possible below synchronous speed. Alright? Only with the squirrel cage induction machine, motoring is always below synchronous speed, generation is always above synchronous speed. But we are not using squirrel cage induction machine in all the locations. Most of the windmills are phase wound induction machine, which is otherwise known as a doubly fed induction generator. So we will be able to inject the power to the rotor also, phase wound induction machine. Is there any question here? This is about motor, right? PM is about the motor, just to explain. Mechanical power comes from the turbine. So this T is the counter torque by the machine. Okay, T applied, torque is being applied by the windmill, and this is the counter torque. And if the speed is above the speed of the magnetic field, then the power will be going like this. If the speed is below the speed of the magnetic field, we will have to inject power to the rotor circuit. If you have a squirrel cage induction machine wherein we are not able to access the rotor winding, and also the synchronous machine wherein the active power flow is only from the stator. That time the rotor is not shown, that DC supply that is not shown. So then you have the power electronic converter. That power electronic converter should have the semiconductor devices which will be able to process dash megawatt. Let's say one windmill is for 10 megawatt, so that 10 megawatt power is being processed by this power electronic converter. Now you come to this doubly fed induction machine. Once again the windmill is same 10 megawatt. Okay. Now this power is 1 and this power. So what may be the power level of this power electronic converter associated with the rotor circuit? It is SPG, right? SPG, yes, you know the typical value is 3%, 4%, 5% and so on, right? Let's say 5%. So 5% of the power. So obviously what I should have shown, no, this power electronic converter, this box should have been very small compared to this, right? But once again, no, the similar active power level is being processed, 10 megawatt that's being processed, but this power electronic converter will be very small in size. It is given in the book as 1/3. 1/3 is not required actually. Any question? Now options are given. Tell me about the speed range of this system. 2 options are there. Variable speed, very good. Tell me about the speed range of this one. Anji? Two options are there. First you choose the option, then I will ask something more. Fixed. Okay. This speed range is definitely less than this speed range. What is the speed range? In the first one, you can have the entire speed range, entire thing. Whereas in the second one, the speed range is restricted only for this. Is that understood? Right? Because you cannot have this point because the stator is permanently connected to the grid. That means that synchronous speed is already fixed. So below synchronous speed, that range, let's say 50 RPM, and above synchronous speed 50 RPM. So it is something like 100 RPM. But if you have only squirrel gauge induction machine, it is only 50 RPM. From 1500 to 1550 RPM. Is that okay? Not okay. Okay. The question is speed range of the first one, synchronous machine or squirrel gauge induction machine wherein you have a frequency converter, AC to DC, DC to AC. If that is there, then you can have so many such characteristics, right? So the entire speed. So you need not worry about, suppose after the turbine, if the speed is 1550, then only it is a generation. Even if that speed is 200 RPM, 300 RPM, it is possible. So then now we can shift the characteristic. Shifting the characteristic is possible if there is a frequency converter between the grid and the stator. All right. Whereas in the second one, I have directly connected the grid to the stator. So that means it is fixed. NS is fixed. So around NS only I can operate. Right? But then by having this power electronic converter in the rotor circuit, I can go for a subsynchronous operation also. So therefore, if this is a 50 RPM, so 100 RPM range only is possible. All right? So then, suppose if the speed is somewhere here, what I have to do? I have to go for a gear system. I will have to change so that the speed seen by the rotor is around 1500 RPM. If the gear system is not there, even this doubly fed induction machine is of no use because we cannot restrict the speed range should be around 1500 RPM. It could be 800 RPM. So obviously it is not possible. Then we will have to depend on the gear system. Is that understood or not understood? So here the gear system is very important. Here even if, I don't know, it's written in dotted line. Even if gear system is not there, it is okay. Why? 200 RPM, it's okay. 200 corresponding frequency, even it is a 12 Hz, 15 Hz, it's okay. But whereas here it is connected. So obviously the speed of the magnetic field is 1500 RPM. So generation is possible once the rotor speed is around that. But below or above. Above means it's obviously immediately you will take the power from the rotor circuit. Below means you will have to do some adjustment. You have to inject appropriate amount of power, and also you will have to ensure that the 3-phase supply that is coming out of this should be synchronized with the EMFs induced in the rotor winding. appropriate voltage and frequency, phase sequence, phase, all these 4 conditions. Okay, right, same thing. So these are the requirements. If you want to integrate the power that is generated out of this wind energy conversion systems, you will have to take care of all this active and reactive power control, frequency voltage control, power quality, fault ride through capability. In case of, even if there is a fault, how do we get a sustainable power system? And then the last point is the dynamics of the generator. When I put a load, when I switch on, instantaneously the power requirement for the load should be met. Correspondingly, there has to be a generation, right? But if the communication is done after some delay, so then it is not a proper power system. So for that, for the generator to respond faster, like motor, for the motor to respond faster in line with the command, we go for the field oriented control, vector control. Similarly, this ABC to DQ transform, all that is to be done so that the generator responds faster to meet the power requirement, load requirement. So if you want to focus on fault ride through capability, instead of AC system, you will have to go for DC. Why? Because if you are having a AC system, whenever there is a grid fault, then the excessive fault currents are induced in the stator windings. But if you go for a DC system, then there is a some kind of isolation is there. So therefore, if HVDC transmission is coming up in lot of locations, then there is a possibility that fault ride through capability is achieved with this wind energy conversion system. But right now it is a phase wound induction machine for AC. Okay. So this part we had seen earlier. The flux producing current component, torque producing current component is being decoupled and they are orthogonal to each other. Therefore, the change of one variable is not going to affect other variable. So keeping this in mind, this field oriented control has come. So there is a popular statement in books, induction machine is inferior to DC machine with regard to dynamics. DC machine can respond instantaneously, whereas the induction machine takes longer time. But by having appropriate control, by decoupling this, by having this the resulting magnetic field into 2 components, x and y axis, d axis and q axis, it is possible to achieve faster response. So then instead of saying that the induction machine is inferior, the control that we have opted for machine is inferior, not the machine. Otherwise, no, induction machine is a maintenance free, rugged, right? So when I make this statement, again people say, no, you want to support Tesla, so that way you are manipulating this statement. So issue is not with the machine, that's what I'm saying. Issue is not with the machine. Wind turbine and then power electronic converter, generator. Okay, what it says is this blue color stands for the electronics. 1980, they were capable of making 50 kilowatt mechanical turbine, mechanical integrity, whereas the semiconductor devices were restricted only for this much. The semiconductor devices rating, voltage rating and current rating. So with the time there was an improvement. Now whatever is the requirement in the mechanical side, right? So that much it is possible to achieve from the semiconductor size, semiconductor devices side also. Whether this is understood? Not understood? So this is about different machines, the share. Mostly it is a doubly fed induction generator, okay, at a different timeline. But now there is a decline because with the HVDC transmission, it is possible to bring this squirrel gauge induction generator. The squirrel gauge induction generator is going up. Therefore, the share of doubly fed induction generator is coming down. Okay, even then, doubly fed induction generator is taking a major portion. So this is about the failure rate and then downtime. if it is a turbine, if there is a problem with the turbine, so what is the downtime that is shown below this line. And for the electrical side, generator, electronics, the downtime. In some locations, there is a damage in the turbine shaft as well as the blade. It is because of the resonance between that power system swing. That frequency coincides with the natural frequency of the system. Whenever there is a coincidence between the external frequency and the natural frequency, all the systems exhibit some oscillations. So even this is also exhibiting some oscillations of certain frequency. In case if there is a coincidence, it results in resonance. Earlier when an army was marching in a bridge, US, that bridge got collapsed because it was a coincidence that the natural frequency of the bridge coincided with the way the army was marching. So since there was a coincidence and it led to resonance, and finally the bridge got collapsed. So army is advised everywhere not to march on rhythm, especially on the bridges, right? They were advised to control their emotions, at least in the march. So this part we have seen. Suppose if it is an offshore project, just to you can see that grandness of this wind turbine. So the guy is standing here. So maintenance is a big concern for offshore projects. So direct drive or gear drive, by eliminating one component, that gear, it is possible to have a better reliability. Right? So some question is asked, which generator is preferred for, what are its advantages and disadvantages? So which one you will go for it? Induction, suppose if you choose induction generator, which one you will choose? Squirrel gauge rotor or phase bound rotor? Squirrel gauge, great man. Suppose if you choose synchronous generator, whether you will go for permanent magnet or electromagnet? Earlier I said no, most of the time first option will be the correct option. You people don't trust till the end, I think. Don't trust me till the end, I think. Electromagnet means you will have slip rings and brushes, right? Right, so you will have the windings. And then with the time, brushes need to be replaced. So maintenance requirement is more. Although with the permanent magnet, we are losing something. What losing? Controlling the field current. We are losing it. Intensity of the magnetic field, we are losing that control. But even then, right now the concern is how do we address the maintenance requirement, okay? So it's a permanent magnet and squirrel gauge rotor, in case if you choose induction generator. So again, now it's a quiz time, okay? So with that I will end actually, because it is up to 2:45. Then after that feedback session, all that is there. First one, please respond to the question. For maximum wind power extraction, dash speed range is preferred. Why? Very nice. Is it because of first option? Okay. Wide speed range, why? It's a very simple question. Wide speed range, why? Correct. We can't dictate the wind, okay? So please cooperate with us. We are interested in generation from renewable energy. So the speed can be anywhere. So obviously wide speed range is the preferred one. For less maintenance, which machine is preferred? Induction machine, because we have slip rings and brushes in synchronous machine. For cost effective solution, which drive is preferred? So you are like one student in IIT Gandhinagar. After getting the degree certificate, she was saying about some other professor. That professor is very innocent. Okay. So generally, faculty members will not be happy if the student appreciate other faculty member. Okay, that professor, let the professor be innocent. But what about me? No, I don't want to comment about you. No, go ahead, please. Feel free. Whenever somebody says no, feel free. English is a very typical language. Some of the letters are silent. For example, iron, I-R-O-N, we don't say iron, we say iron. But the human being sentences, it's very different. Some of the words will be silent. Feel free. After that, few words are silent. What? Feel free to say what I wish to hear. Right? But that is silent. And she said, no, you have a criminal mind. And she was telling, she was from a first batch students of IIT Gandhinagar. She was telling after receiving the degree certificate, because I was the faculty advisor. After receiving the degree, you are having criminal mind. Why you are saying I am having criminal mind? Because it was her final year project. Final year project was BLDC motor. So she started, and her supervisor called me, please evaluate. I was the examiner, please evaluate. She started BLDC motor control, sort of BLDC motor. Please tell me the working of a DC motor. BLDC motor slightly advanced. Please explain the working of a DC motor. Then she started crying. Then I said, please go out, cry, and then come. So after 10 minutes, she came inside. Control of BLDC motor. Stop. Please explain the working of a DC motor. Again, she started crying. Our supervisor was saying, why are you disturbing my student? You call me to examiner, I just ask, explain the working of a DC motor because it is simple. After that, you can go to BLDC motor. But she was crying. Then he was saying, why are you disturbing my student? Then I had a pen. I threw the pen. Okay, you please evaluate your student. I am going out. I walked out. After that, I met her in Bangalore. I went to her home. Okay. So what she was telling me, criminal mind, you know that I am acting. Actually, she was acting. I know, but her supervisor doesn't know that she was acting. It's not like that the tears were coming. If she is pretending like that, she was assuming that I will not ask question. But I know that she was acting. And she know that, I also know that. But her supervisor doesn't know. That's why she said, my supervisor is very innocent and you have a criminal mind. And similarly, although I said the first option is correct most of the time, and you are also thinking that I have a criminal mind, so it could be second option. For cost-effective solution, why gear drive is preferred? Cost-effective solution means you please think in terms of the size of the machine. In which situation size will be geared, okay? Because the moment you go for a high speed, although that side speed is less, if you make it high speed, the generator will be seeing high speed. So therefore, the generator size will be less, right? So for grid stability, power regulation is done through control. What control? I have not given options for a change. She is looking, where is option, right? So you can say field oriented control, that ABC to DQ transform you can do, so that the change of one quantity doesn't affect other quantity. You will have instantaneous response. You want certain amount of active power, certain amount of reactive power. Whatever reactive power is coming, let's say it's enough, right? Now I want to have additional active power. So only that particular quantity, that particular current I want to change. Therefore, the response will be faster. Response will be faster means when I switch on, immediately it's being supplied. Same generator, but by having this control, the power requirement of the load can be instantaneously met, whether it is a reactive power requirement or active power requirement. For offshore projects, again there is a change. It's a option, fill up the blank, and directly it's a descriptive question. So for offshore projects, which generator is preferred? Anji? Induction generator. Which induction generator? So actually it is a permanent magnet synchronous generator. The reason is permanent magnet synchronous generator with the power electronic converter to the stator side, and instead of electromagnet we will go for permanent magnet, so that will be better. Once again, when you go for PMSG, the size will be slightly lesser than that of the induction generator. Okay. For offshore projects, which drive is preferred? Direct drive, very nice. With regard to fault ride through capability, which machine is preferred? Fault ride through capability means whenever there is a fault, how it is reflected in the stator windings. So when it is talking about reflection in the sense induced will happen whenever? With AC, right? This is the hint. So assuming HVDC transmission, then actually question is incomplete. Assuming HVDC transmission, then it is a squirrel gauge induction generator. Correct? No? Thank you very much. Any question? So it was told 245 through 40. Any questions? Thank you very much.